All right, we're in the linear programming section of the notes doing example LP1. All right, so here's the question. So I want you to make sure you have this in front of you as you work through it. We'll show it here at the beginning, but as we work through this problem, this is what we want to think about. So we are a furniture manufacturer and we're producing two types of tables, a country table or a contemporary table. All right, to produce this table, it requires three different machines. It requires a router, a sander, and a polisher. All right, so to make a country table, it takes 1.5 hours on a router, 3 hours on a sander, and 2.5 hours on a polisher. Contemporary table requires 2 hours on a router, 4.5 on a sander, and 1.5 on a polisher. So that's what it takes to make one table. Now we have total machine time available per week as 1,000, 2,000, and 1,500 for each of them respectively. All right, our country tables sell for $350, contemporary for $450. Management has determined that at least 20% of the tables made should be country and at least 30% should be contemporary. So the question is, how many of each type of table should the company produce if it wants to maximize its revenue? Okay, so let's set up our linear program by hand and then we'll do it in Excel. So step one is to define our variables. Let's let x1 be the number of country tables we make. Okay. Let x2 be the number of contemporary tables that we make. Okay. Second step now is, what is our objective function? Well, if we go back to the question, it says, how many of each type of table should the company produce if it wants to maximize its revenue? So our objective here is to maximize revenue. Well, revenue equals, the question says, country tables sell for $350 each one. So we get 350 times the number of country tables we make plus 450 times the number of contemporary tables we make. So there is our objective function. Now, third step, let's look at our constraints. So the first constraint we can think about is that we have a machine constraint. All right, this is similar to what we've had before. So we have country tables. We have contemporary tables. All right, and each one requires a router, or time on the router, time with the sander, and time with the polisher. Kind of sounds like the song Mamba No. 5, but we digress. All right, so the country table takes 1.5 hours on a router, 3 hours on a sander, and 2.5. Contemporary 2, 4.5, 1.5. Now this is very similar to what we've done before. All right, and we know that the time they spent has to be less than or equal. So here's our constraint, is we have 1,000 hours here, we have 2,000 hours here, and 1,500 hours there. So the router is 1.5 times the number of tables of x1 that I make, of the country tables, plus 2 times number of contemporary tables that I make. And 1.5 x1 plus 2 times x2 has to be less than or equal to 1,000. And same thing here. And this is very similar setup to what we did with example 1. All right, but now there's this management issue. So management says that 20% of the tables have to be country and at least 30 have to be contemporary. All right, so we want to think about is that country tables have to be at least 20% of our total tables. So we'll do 0.20, there's our 20%. Well, what's our total tables that we make? Well, it's the number of country plus the number of contemporary. So x1 plus x2. That's our first constraint with what management says. Our second is that contemporary tables need to be greater than or equal to 0.35 times x1 plus x2. We have that, and now we've set up our linear program. That's what this is called, the 3 steps. And now we're ready to go to Excel and solve it there.